The following is a neuroanatomical overview of the motor system. Voluntary movement is initiated in the primary motor cortex, where there is a somatotopic map of the body. Primary motor cortex functions mainly to execute movement. Cortical spinal fibers originate from the pyramidal neurons in layer 5 of the cortex. M1 cortical axons from the cortex communicate with the spinal motor apparatus either directly or indirectly via brainstem spinal systems. The supplementary motor cortex lies rostral to M1 near the convexity of the hemisphere and extends onto the medial wall of the hemisphere. It is involved in organizing or planning the sequence of muscle activation required to make a movement. The premotor cortex occupies the portion of area 6 lying just rostral to the anterolateral part of M1 and contains a somatotopic representation of the body. The premotor cortex receives considerable input from sensory areas of the parietal cortex and projects to M1, the spinal cord, and the reticular formation. The motor regions of the posterior parietal cortex, and it is important for making movements in space. Area 5 receives extensive projections from the somatosensory cortex and input from the vestibular system, whereas Area 7 processes visual information related to the location of objects in space. Both areas project primarily to the supplementary and pre-motor cortices and have few spinal or brainstem targets. The cingulate cortex neurons project to the primary motor cortex and spinal cord. These motor neurons may be involved in movements that have intense motivational or emotional components. The basal nuclei and cerebellum play essential roles in the control of movement through their interaction with motor-related areas of the cerebral cortex. The cerebellar nuclei and the globus pallidus each project primarily to their own spatially segregated regions. In the ventral anterior, ventral lateral, and oral parts of the ventral posterior lateral nuclei of the dorsal thalamus. These so-called motor areas of the thalamus give rise to the thalamocortical projections to M1 and the supplementary motor area. The thalamic areas that receive input from the globus pallidus project mainly to the supplementary motor cortex, and the thalamic areas that receive input from the cerebellum project to M1. Signals transmitted from the corticospinal and corticonuclear systems can be modified by outputs that reach the cortex from the cerebellum, basal nuclei, and thalamus. The cerebellum is composed of a highly convoluted cerebellar cortex and a core of white matter containing the cerebellar nuclei. It is anchored to the brainstem via the cerebellar peduncles. The cerebellum is located superior to the brainstem, inferior to the tentorium cerebelli, and internal to the occipital bone. The cerebellum receives input from many areas of the brain and spinal cord and influences motor performance.